This is section 4.1 in the middle of page 4. The closed interval method to find the absolute maximum and minimum values. These are your extreme values, your extrema, of a continuous function f on a closed interval from a to b. First thing is you have to find the values of f at the critical numbers of f on that closed interval. Make sure the critical values are in the interval. Step 2, find the values of f at the endpoints of the interval. And then step 3 is the largest of the values from step 1 and 2 is the absolute maximum value, and the smallest of those values is the absolute minimum value. So we have a few examples that go over these ideas of the closed interval method. The first one says to find the absolute maximum and minimum of f of x on the interval from 0 to 6. There's a graph here to look at also, but let's just pretend the graph is not there and just go through with the algebra of the problem. So first thing is we need to find the derivative. So f prime of x is equal to, taking the derivative of our cubic function, we get 6x squared minus 30x plus 24. And it says we have to find all the critical numbers. So in order to do that, we have to set this equal to 0. To solve this, we need to factor out a 6. And we have 6 times x squared minus 5x plus 4 equals 0. And then we can continue to factor this, and we have 6 times x minus 1 times x minus 4 equals 0. So we get x is equal to 1 and x is equal to 4. These are both my critical values or my critical numbers. The second thing is to find the f values at these critical values, which corresponds to our y values. And then we also have to find the y values at the ends of the interval. So I need to find f of, our interval starts at 0. I have to find f of 1, f of 4, and then our interval ends at 6, so we need to find f of 6. So you need to substitute these back into your original function, f of x, which is up at the top and typed. So f of 0 is 7. So substituting 0 for x. Substituting 1 for x, we get 18. F of 4 is equal to negative 9. And f of 6 is equal to 43. So these are all your y values that you have, these corresponding x values. And so your absolute minimum occurs at the smallest y value, which is at negative 9. So you have an absolute min at, and we're going to go ahead and write this as an ordered pair. This is 4 comma negative 9. And then your absolute maximum occurs at the largest y value, which is 43. So this is our absolute max, and it occurs at 6 comma 43. And there's a graph on here too, and looking at the graph you can see those absolute maximums and absolute minimum values. Another way to do this would be to graph it on a graphing calculator and actually figure those out. But using the calculus approach and using this closed interval approach, it allows us to do that without actually graphing our function. So there's another example on the next page. It says find the maximum and minimum values of f of x equals, and it says on the interval from negative 1 to 2. So again, the graph is given to you. However, let's pretend that that's not there and go on with the problem. So we have to first take the derivative of this function. So f prime of x is equal to, this is going to become negative 2/3 x minus 1 to the negative 1/3 power. And then I'm just going to go ahead and rewrite this as negative 2 over 3 times the cube root of x minus 1. And so in order to find our critical values, we have to see where would this derivative equal 0. And it's never going to equal 0. But you can also have critical values where the derivative is undefined. So f prime of x is undefined when the denominator, which is 3 times the cube root of x minus 1 equals 0, which if you solve this, you will get x is equal to 1. And so this is our critical value. And also I want you to realize that this is in our domain. The domain of this function is all real numbers. So we need to figure out, and this number is also in our interval, and our interval was from -1 to 2. So we need to find f of -1, f of +1, and f of 2. And again, 1 is my critical value, and -1 and 2 are for my endpoints. So substituting this in, I get 1 minus -1 minus 1 to the 2/3, which, let's use a decimal approximation here, and I'll just round 2 decimal places, which is -0.59. Plugging in 1 into my original function, we have 1 minus 1 to the 2/3, which just equals 1. And then substituting in 2 into my original function, I have 1 minus 2 minus 1 to the 2/3, which equals 0. So our absolute min occurs at the smallest y value, which is that -0.59. So this would be our absolute min. And our absolute max would occur at the largest y value, which is at +1. So this is our absolute max. And again, they would like for you guys to write your answers either as ordered pairs or in function notation. So I will write them as ordered pairs. So your absolute min is going to be -1, comma, and we'll write it as a decimal, -0.59. And your absolute max is 1, 1. And again, you can look at your graph to see where that absolute max occurs and to see where your absolute min occurs.